Hello students, I am A.D. Borude, PGT Physics of the JNU Washington. Would like to explain the current electricity, which is a second unit of the class 12th physics, which has a 7 marks in the board examination. Let us start unit current electricity, which is divided into two parts. First part include electric current, drift velocity, current density, Ohm's law, resistance, resistivity, conductance and conductivity, temperature dependence of the resistance, color code of the carbon resistors, series and parallel, combination of the resistors, EMF and potential difference of the cell, internal resistance of the cell, series and parallel combination of the cell. Let us start the current electricity part 1. What is the electric current? The electric current is defined as the flowing average charge flowing through the any section of the conductor in a 1 second. It means when charges are flowing through the conductor at a one particular section, the number of charges passing in a 1 second. This is known as a current. It is a denoted by I equal to charge Q divided by T. Q is the charge, T is the time. If rate of flow of the charge is steady, we can use this formula. If the rate of flow of the charge varies with the time, then I is equal to dq by dt. There are the two types of the current, direct current and alternating current. Direct current is steady current which does not vary with the time, and alternating current whose magnitude varies continuously and direction is a change periodically. In a electric current, when it is a flow through the wires, in a closed circuit, it is indicated with the arrows, and the indication of the arrow in an electrical network, this is known as the direction of the conventional current. The conventional current is the direction along which the motion of the positive charge flow under the action of the electric field. The conventional current is always indicated from the positive charge of the battery to the negative charge through the conductor. This is known as a conventional current. But flow of the electrons is from the negative terminal of the battery to the positive terminal through the conductor, just opposite to the direction of the conventional current. Then what is the drift velocity? When potential is applied across the conductor, electrons start flowing through the conductor. Means it is flow from the one place to another with this velocity. It drift one place to another. This known as a drift velocity. It is defined as a velocity with which free electrons get drifted toward the positive terminal under the effect of the electric field. This is known as a drift velocity. Then we have to derive the. Then there is a 3 marks question on the drift velocity or 2 marks question. They show that current is directly proportional to the drift velocity, or the question is show that r equal to that m l divided by n e square tau into a. This is the 3 marks question most of the time asked in the board examination. So let us start the derivation. Consider this a conductor of a length L and potential E is applied across the conductor. This arrow shows the direction of the conventional current. Consider a conductor of the length L and under the influence of the electric field E, free electrons experience a force F is equal to minus E into capital E. E is the charge on the electron and capital E is the electric field. The negative sign shows that F and E, they are opposite in a direction. According to the Newton's second law, force equal to mass into the acceleration. Therefore acceleration equal to force divided by mass. Substituting the value of F from this E capital E divided by m. This is the acceleration. The first equation of motion is Vd, this is drift velocity, equal to u average plus E into tau. This is u average. This is the average thermal velocities of the electron. They are moving in a random. So total velocity, average velocity is say 0. And this tau is a relaxation time. This is a time lapse or time between the two successive collision. This known as a relaxation time. Substituting this value V average equal to 0, the Vd in a mode equal to E capital E by m into tau. Then current flowing through the conductor having a is the area of the cross section and n is the electron density, L is the length and E is the charge on the electron. The current I is equal to total charge divided by time, and total charge equal to charge density into volume. AL is the volume term, E is the charge divided by this is the time equal to this is length divided by velocity. Therefore, I equal to N E in A into Vd. So I is a directly proportional to Vd because this is a N, E and A area of the crossing, all these are constants, so I is directly proportional to the velocity, drift velocity. Current flowing through the conductor is a directly proportional to the velocity, and where N, E and capital A area of the cross section, charge and electron density is a constant. Then the current density at a point is the current through the unit area of the conductor around that point, provided the area is a perpendicular to the direction of the flow of the current at that point. J equal to current density J equal to I divided by A. Substituting the value of the I, the current density equal to NE into Vd. Then Ohm's law. Ohm's law, it is a law in an electric network. Is a relation between the potential difference and current. It is stated that electric current flowing through the conductor is directly proportional to the potential difference across the ends of the conductor when physical conditions such as the temperature and mechanical strain etc. is remain same. V I is directly proportional to V or V is directly proportional to I. That proportional constant is known as a resistance. It is denoted by R. So V is equal to R is a constant into I. When it is denoted with the graph potential versus I, the graph is a straight line, which indicates it is a directly proportional relation. And this constant V divided by I, potential divided by current, this is always constant. This known as a resistance. So let us define the resistance. Resistance of the conductor is a opposition offered by the conductor to the flow of the current through it. R is equal to V divided by I. And unit of the resistance is a ohm. The resistance in terms of the physical features of the conductor, I is equal to NEA into VD. Already we derived this relation. Substituting the value of the VD in this relation, then I is equal to N E square A tau V divided by I divided by this M. V divided by I, this is a term, is a place E equal to V divided by L. Rearranging the term, V divided by I equal to ML divided by N E square A into tau. V divided by I is a R, this value is here, and M into L divided by Ne square tau into A. This is the term, this known as a resistivity. The resistivity is denoted by rho M N divided by Ne square into tau. The resistivity, or this known as a specific resistance. If this resistivity is constant, so R is equal to rho L divided by A. Means resistance of the conductor is directly proportional to the length and inversely proportional to the area of the cross section. And resistivity depends on the nature of the material and not on the geometrical dimension of the conductor. SI unit of resistance is ohm meter. Relation between Vd, resistivity, I, electric field, electric density, current density, and potential. So rho resistivity is E divided by J. E is the electric field. So substitute this value of the J N E in by Vd. And Vd equal to E divided by Ne into rho. Rearranging this term, Vd is equal to V divided by Ne rho into L. When temperature is increases, drift velocity increases and resistivity also increases. When current increases, Vd decreases. When current increases, when current, when I increases, Vdj decreases. The conductance is the reciprocal of the resistance. Its unit is a just a reciprocal of resistance. It is a unit is a mho or mho. This just reverse to the ohm. Conductivity is a reciprocal over resistivity, and unit is a mho per meter. Then this resistance is it depends on the length and area of the cross section. So length resistance is directly proportional to the length and inversely proportional to the area of the cross section. Also it is depends on the temperature. When temperature increases, the average relaxation, all these terms m, l, a, n, e square, all these are constant. It is a resistance is inversely proportional to the relaxation time tau. When temperature increases, number of collisions increases due to the more internal energy and relaxation time decreases. The relaxation time decreases means therefore resistance is a increases. What is the effect of the temperature on the resistance of the conductor? So the effect is when temperature increases, resistance is a when temperature increases, resistance also increases because temperature increases, number of collisions due to the more internal energy increases, relaxation time decreases, therefore resistance is a increases. Temperature coefficient of the resistance, this is denoted by alpha. Alpha equal to change in resistance divided by original resistance and change in a temperature. So this known as temperature coefficient of a resistance. Resistance of the conductor, it is a directly proportional to length and inversely proportional area of the cross section, and this proportionality constant, this known as a resistivity. So R is equal to m n e m divided by n e square tau L divided by A. What is the rho is a resistivity. So rho equal to m n e square into tau divided by tau. R is a directly proportional length of the conductor. R is also inversely proportional to area of the cross section. So this resistance is a used in electrical network having a certain codes or color bands over the resistance, and it is a use to measure the value of the resistance on the using this color bands. So generally in a simple carbon resistance there are the four bands. Three bands are close and one is a very widely separated from this three closer bands. So how to find the value of this resistance by using the color bands? This is the question. So this two three bands which are closer as shown in this diagram. These three bands which are closer, and this is the fourth band is widely separated. Let us start the measuring value of the resistance from the three closer band. The is a first band, first two rings from the end give the first two significant figures of the resistance in ohm. Means these are a total this 10 numbers or colors having a given the number. This is a letter black, brown, red, orange, yellow, green, blue, violet, gray, and white. The black is a 0, brown is a 1, red is a 2, orange is 3, yellow is a 4, green is a 5, blue 6, violet 7, gray is 8, and um, white is a 9. And this fourth band, which is very widely separated on the resistance, having a color gold, silver, and no color. If this band is a gold, there is a 5% tolerance. Tolerance. Silver 10% tolerance, and no color there is a 20% tolerance value. So let us find or how to remember these color bands. There is a one sentence: B.B. Roy of Great Britain has a very good vibe. So first color B is for the black, second is a brown, this is the R for the red, orange, yellow, G for the green, this is the blue, and V for the violet, gray, and white. This is the order of the colors arranged in this table, and their numbers are arranged. How to write the value of the resistance? Just look at this value of the resistance. Take the example. This is the first is the color is a brown. So write the first color number. Brown is a 1. So 1 is written here. Then what is the second next is it is a violet. So violet color number is a 7. So 7 is written here. Into third is a 10th power multiplier. So 10 raised to the third color is a brown. Brown third is a not a brown, it is a black. So black 10 raised to the 0. So value of the 10 raised to 0 means 1. So value of the resistance is 17 ohm. But this value is a not a, that depends on the temperature. So it has a tolerance. It may vary plus minus 5% because gold has a 5% of a tolerance. Let us take the another example, another resistance. The first band is a green. So value of the green is a 5. So 5 is written. Second is a red. Red number is a 3, a 2. So 5, 2. First two numbers written as it is into 10th power of a third color. Third is a blue. So 10 raised to 6. And silver having a tolerance is a plus minus 10%. The value is in a ohm. In this way, the value of the resistance is a calculated by using the color band. So let us try for the yourself. You try for the third example by using this table, and in this way the value of the resistance it is a written or identified by using the color bands. Or another method to measure the value of the resistance is using the multimeter we can use to measure the values. This resistance in a market there is a certain resistance are available, but when we require the particular value of the resistance which are not available with you or in a market, in that case we can combine the values of the combine the resistance and we get the or we can get the desired value of the resistance. So the combination of the resistance can be takes place either in a series or parallel. Series when we connect the resistances are in series means one connected to the another as shown in the figure. As shown, this R1 is connected, R1 is connected to R2, R2 is connected to R3. Then total resistance of the combination is equal to R1 plus R2 plus R3. The resistance in a parallel they are connected in this way. all the resistance arranged in a parallel, and they are having a common two ends. And this equivalence, a total resistance equal to reciprocal of a 1 by R, this parallel equal to 1 by R1 plus R1 by R2 plus 1 by R3, means sum of the reciprocal of the all the individual resistances. In this case, R is smaller than the smallest of all. It this R, इसमें से सबसे जो छोटा रेजिस्टेंस है उससे भी इसका इक्विवेलेंट रेजिस्टेंस क्या आता है, छोटा आता है. So already this combination of the resistance you you studied in the class 10th how to connect the series and parallel to get the desired values. Now the source of the EMF, the EMF means electromotive force. What is the electromotive force? Electromotive force is the maximum potential difference between the two electrodes of the cell when no current is drawn from the cell. When we purchase the cell from the market, its EMF value is 1.5. This is the EMF. And then this is the comparison between the EMF and potential difference. EMF is the maximum potential difference between the two electrodes of the cell when no current is drawn from the cell when it is a open circuit. And potential difference is the potential between any 2 points in the closed circuit. When circuit is closed, uh, there's a difference in the potential. The EMF is always greater than the potential difference. It is a independent of the resistance of the circuit, because circuit is open, then independent on the resistance of the circuit. It is a proportional to the resistance between the given points. And that term EMF is used only for the source of the EMF. Term EMF used only for the source of EMF, and it is a measured between the any 2 points in the circuit. It is a greater than the potential difference between any 2 points in the circuit. However, potential difference is a greater than EMF when cell being charged. Only in case of the charging, the potential difference is a larger than the EMF of the cell. Then internal resistance of the cell. What is the internal resistance of the cell? The internal resistance of the cell means resistance offered by the cell due to its electrode and electrolyte. The, re- the opposition offered by the electrode of the cell to the flow of the electric current through it is called as internal resistance of the cell. Actually, internal resistance it is a depends on the it is depends on the electrode, electrolyte, or area of the plate, and these factors affecting the internal resistance of the cell means internal resistance means the resistance offered by the cell due to the electrode and electrolyte. This is known as the internal resistance. The factors affecting the internal resistance of the cell, larger the separation between the electrode of the cell. There are the two electrodes are used to manufacture or prepare the cell. It is a cathode and anode. So internal resistance depends. It is a larger separation between the electrodes of the cell, and more is the length of the electrode through which current has to flow, and consequently a higher value of the internal resistance. When the separation distance between the two electrodes is larger, internal resistance is large, and greater greater the conductivity of the electrode, lesser is the internal resistance. कंडक्टिविटी अगर ज़्यादा है तो internal resistance is a smaller. Internal resistance depends on the nature of the electrodes. Nature of the electrode, it depends. Internal resistance of the cell is inversely proportional to the common area of the electrode dipping in the electrolyte. If electrolyte area is a larger, internal resistance is a smaller. It is inversely proportional. So what are the factors affecting the internal resistance? It is a when separation between the two electrode is larger, the internal resistance is higher. It depends on the conductivity of electrolyte conductivity, and that's a depends on the nature of the electrolyte. Internal resistance is inversely proportional of the area of the that electrodes. and it is denoted by E is the EMF, V is the potential difference, and in a, let us see this is circuit. This is the battery, and this is the internal resistance of the cell, which is denoted at the negative terminal of the battery. And when in a closed circuit, when R is the external potential is external resistance is applied in the circuit, and current starts flowing through the circuit, the potential is a capital V across the external resistance, and small v is the potential drop across the internal resistance. So E is the EMF equal to potential across this external resistance plus potential across the internal resistance. So according to Ohm's law, V is equal to IR, and this is the I is the current flowing through internal resistance, and potential is a having a value is R, and potential is a small v. So rearranging the term, this is I is equal to E divided by R plus small r. This relation is called as a circuit equation. In the combination of the cells can be connected in a series or parallel. Then what will be their equivalent resistance? Equivalent resistance as well as effective EMF of the cell. Means one positive is connected to the negative, and again negative to the positive. This is the arrangement. This known as the arrangement of this resistance in a series, or cells are connected in a series. When negative of the one cell is connected to the positive of the other, in this way this arrangement known as a series resistance. When resistance are connected in series, their effective EMF, total EMF of the battery, is n times of a E. N is the number of identical cells. If there are the n number of cells, suppose 5 cells are connected, each having a potential is a 1.5, then 5 multiplied by 1.5. In this way, total EMF. And internal resistance of cell is a n times of the R. If there are the 5 cell, 5 into R of R. Total resistance of the circuit. Total resistance means internal resistance NR plus external resistance R. This sum is a total resistance. And what is the current? Current in the circuit equal I is equal to NE total potential EMF divided by total resistance. In this way, when internal resistance is a negligible, when internal resistance is negligible, uh, negligible in the comparison with the external resistance, the cells are connected in a series to get the maximum current.